Driving around Houston on the Interstate 610 loop, Pentagon T and Toops Graphics presents an Algebra 1 tutorial video over exponential functions application problem. Remember, in Algebra 1, exponential functions are written in the form y equal a times b to the x, where a is the y-intercept and b is the common product. The graph of an exponential function is a curve that slants upwards or downwards. In the function y equal 4 times 2 to the x, a is 4, which turns into the y-intercept, and b is 2, which is our common product. The y's change by a product of 2 as you go down. You need to also remember that exponential graphs in the form y equal a times b to the x power will approach but never cross the x-axis. The x-axis is called an asymptote. Also remember that b will determine if the graph has decay or growth. If your b value is between 0 and 1, the graph will have decay and will go down from left to right. And remember, if b is more than 1, the graph will have growth and will go up from left to right. The graphs of growth and decay look like this. If your b term is more than 1, the graph will go up from left to right. If the b term is less between 0 and 1, then the graph will go down from left to right. Now let's look at some application problems involving exponential functions. Problem 1. A fire ant bed has a population of 20 ants. Every day the population of the ants will double. What will the population of the ant bed be after 7 days? To do this problem, we need to find the starting amount and the common product. To find the starting amount, we need to look at how many ants were in the ant bed, which was 20. To find the common product, what word tells us what's going to happen to the population of the ants? The ants will double, so our common product will be 2. Since we know our starting amount's 20 and our common product's 2, now we'll evaluate. We'll put 20 in for A and 2 in for B. That gives us a formula of y equal 20 times 2 to the x power. Now we want to know the population of the ant bed after 7 days. So we'll replace the x with 7. That gives us a formula of y equal 20 times 2 to the 7th power. This is what you will input into your calculator, and you'll get an answer of 2,560. So, after 7 days, 2,560 ants will be in the ant bed. Now we're going to graph this function. To graph the function, we'll only use the first quadrant. We need to know the axis, identify the y-intercept, and identify the point asked for, then draw an exponential growth or an exponential decay curve. First off, let's label the axis. The x-axis will be the number of days, and the y-axis will be the number of ants. The x-axis will usually be a quantity of time. Now we're going to plot the y-intercept, which is 20. So on the bottom of the y-axis, plot a point and put 0, 20. Next, we'll identify the day asked for, which was 7, 2,560. So at the upper right-hand corner of the first quadrant, put 7, 2,560. Now, we'll draw an exponential growth curve which goes up. It will look something like this. This is a rough graph of what this function looks like. Notice that our axes are labeled with the number of days and the number of ants. Our y-intercept is 0, 20, and the curve has exponential growth up to the point 7, 2,560. This Pentagon T Toops Graphics video over exponential functions application problems will be back after this commercial break. Today's video is sponsored by Asymptote. Do you have a line that a graph approaches but never crosses? You have an asymptote. The vertex. Do you know the top or bottom of a parabola? You know the vertex. And Pentagon T. Do you need to believe? You need Pentagon T. Pentagon T is proud to introduce the Algebra 1 cell phone app. It will help you know what the parent linear function looks like. It will help you find the slope given the x and y intercept of a line. It will show you what the parent quadratic function looks like. And it will help you find the zero of a function by knowing that it's where the graph crosses the x-axis or where the y value is equal to 0. It will show you how to multiply binomials by using the full method. It will show you how to get the roots of a quadratic equation by using the quadratic formula. And it will show you that the discriminant is equal to the square root quantity of the quadratic formula. The Pentagon T cell phone app. It will help you always believe. As we continue our travels down Interstate 610 in Houston, the Pentagon T Tubes Graphics Always Believe video over exponential functions application problems continues. Let's look at our second problem. A barn has 800 mice. Poison will kill half of the mice every 6 days. How many mice will be in the barn after a 30-day month? Notice in this problem that the population of the mice won't increase, it will decrease. So we won't have exponential growth, we will have exponential decay, which means our B term will be less than 1. The first step is to identify the A term, which is our starting amount, and our B term, which is our common product. In this problem, our starting amount will be the 800 mice, and our common product will be 1/2, or we could use 0.5 for a decimal. Now we'll input 805/10 into our equation y equal ab to the x power. That will make our equation y equal 5/10 to the x power. Now we need to find our input for our value of x. Notice that we want the value after 30 days, but the ant poison is determined on 6 days. So 6 goes into 30 5 times. So we'll input 5 in for x. That gives us our equation of y equal 800 times 5/10 to the 5th power. You will input that into the calculator and it will give you 25. So after a 30-day month, there will be 25 mice left in the barn. Now let's graph our equation. Notice we have y equal 800 times 5/10 to the 5th power is 25. Let's label the axis, identify the y-intercept, and identify the point asked for, then draw a growth or decay curve. The first step is to label the axis. Our y-axis will be the number of mice, and our x-axis will be the number of days, which is a quantity of time. Now we'll label our y-intercept, which is 0,800. This won't be at the bottom of the y-axis, it will be toward the top of the y-axis. The point asked for is 30 days, but it will be an increment of 5. So put 5,25 at the bottom right of the first quadrant. Now we'll draw an exponential decay curve which goes down and looks something like this. This is what our exponential curve y equal 800 times 5/10 to the 5th power will look like. It will go from 0,800 to 525 and will be an exponential decay curve which goes down. We'll be back after this commercial break. Today's video is sponsored by the domain. Do you know the possible x values of a function? You know the domain. In the problem we just did, our graph goes from an x value of 0 to an x value of 5. So our domain would be 0 less than or equal to x less than or equal to 5. The domain tells you the possible x values of a function. Aren't these 2x plus 1 chicken strip functional meal deals splendid?
That's right, Dad. You pay a starting cost of $1 for the fries, and every chicken strip will grow your cost by $2.
We could use the function rule of 2x plus 1 to calculate our cost.
The regular order comes with an input of 3 chicken tenders for $7.
Or you could get the kiddie order and input just 2 chicken tenders for $5.
Oh wait, or you can get the dinner for 2 that comes with an input of 8 chicken tenders for $17.
Wow.
Yes, wow.
Did you know the amount of chicken strips is the independent variable and the cost is the dependent variable?
That's right, but in other words, to explain all that, the cost is dependent on the number of chicken strips.
Or you can say the cost is a function of the number of chicken strips.
This talk about functions is getting me hungry.
Yeah, let's order the dinner for 2.
The chicken strip functional meal deal. Only at Sonic. As we continue driving down Interstate 610 in Houston, Texas, the Pentagon T Toops Graphics always believe video over exponential functions application problems will continue. Now let's look at what happens when your common product is a percent. If the percentage makes the amount grow, then add your percent to 100. For example, a population of 20 rabbits will increase by 30% each month. In this problem, the population will grow, so we'll add the 30% to 100. 100 plus 30 is 130%, then we'll convert the 130% to a decimal, which will be 1 3/10. 1 3/10 will be our common product. Since the population starts off with 20 rabbits, that will be our quantity of A. So our equation will be y equals 20 times 1 3/10 to the x power. Now let's do problem 3. Emma Sue's apartment has 80 cockroaches. If left untreated, the population will grow by 50% each day. How many cockroaches will be in the apartment after 14 days? Just like the other problems, we need to identify the starting amount of the common product. Our starting amount will be the 80 cockroaches. The common product will be the 50%. Since the population will grow, we will add 50% to 100, giving us 150%. If you convert the 150% to a decimal, you get 1 5/10. Inputting 80 and 1 5/10 into our exponential function, we'll get y equal 80 times 1 5/10 to the x power. Now we need to evaluate for the quantity that's asked. We want the number of cockroaches after 14 days, so we'll replace the exponent of x with 14. Now on your calculator, you'll input 80 parentheses 1 5/10 close parentheses to the 14th power. That will give you an answer of 23,354 cockroaches. Now we can graph this function. Just like the other problems, we'll only use the first quadrant. We need to label the axis, identify the y-intercept, identify the point asked for, then either draw an exponential growth or an exponential decay curve. Let's first label the axis. The y-axis will be the number of cockroaches, and the x-axis, which is usually a quantity of time, will be the number of days. Now we'll draw the y-intercept, which will be 0, 80. Remember, since this is growth, the 0, 80 will be toward the bottom of the y-axis. Now we'll identify the point asked for, which is 14, 23,354. This will be in the upper right-hand corner of the first quadrant, since this is a graph of exponential growth. Now we'll connect the ordered pairs with an exponential growth curve, which will look something like this. This is a graph of the function with the cockroaches increasing by 50% each day to 14 days that starts off with 80 cockroaches. As we pass up the original location of Gulfgate Mall, the first air-conditioned mall in the world, the Pentagon T Toops Graphics video over exponential function application problems will return after this commercial break. This video is sponsored by range. Do you know the possible y values of a function? You know the range. In this graph, our range or y values go from the bottom to the top. The bottom y value would be 25 and the top y value would be 800. So our range would be 25 less than or equal to y less than or equal to 800. The range, it gives you the possible y values of a function.
Have you received a perfect score on a test lately? Now you can give your paper a stamp of greatness. With the Pentagon T Super Toots Genius stamp. Just stamp away on your perfect paper and Shazam! You are now at the elite level of genius at WWJH.
Pentagon T, always believe. As we continue our journey around Loop 610 in Houston, Texas, the Pentagon T Toots Graphics Always Believe video over exponential functions application problems continues. In our last problem, the percentage made the problem have exponential growth. If the percentage makes the amount decrease, then you'll have exponential decay. In that instance, you'll subtract the percent from 100. For example, rat poison will kill 40% of the population each week. Bubba Bob's barn has 800 rats. In this problem, the population of the rats won't go up, it will decrease. Since this problem will have exponential decay, we'll take our percent of 40% and subtract it from 100. 100 minus 40 would be 60. So our common product would be 60%, which converted to a decimal is 6/10. Since the initial population of the rats is 800, that would make our equation y equal 800 times 6/10 to the x power. Now let's look at another problem. Emma Sue's apartment has 20,000 cockroaches. Newton County Exterminator says it can get rid of 60% of the roaches every day. How many roaches will be left after 7 days? To do this problem, we need to find the starting amount and the common product. In this problem, our starting amount would be the 20,000 roaches. The common product would deal with the 60%. Since the percentage is making the population go down, we'll take the percent and subtract it from 100. So 100 minus 60% would be 40%. Converted to a decimal, 40% would be 4/10. So our common product would be 4/10. If we evaluate our equation with 20,000 and 4/10, that would give us a function of y equal 20,000 times 4/10 to the x power. Since we want to know the population after 7 days, we'll replace the variable of x with 7. Now then, we'll have y equal 20,000 times 4/10 to the 7th power. You will input 20,000 parentheses 4/10 close parentheses exponent 7 on your calculator. That would give you an answer of 32 and 768 thousandths. You'll round the 32 to 33. Remember, if your answer is a decimal and it deals with living things, you need to round your answer to a whole number. So, after 7 days, we'll have 33 roaches in the apartment. Now that we know the quantity asked for, we'll graph the problem as is the others. We'll label the x-axis, identify the intercept, and identify the point asked for. As is the others, we'll only use the first quadrant. The y-axis will be the number of cockroaches, and the x-axis, a unit of time, will be the number of days. The next step is to label the y-intercept, which will be 0, 20,000. Since the problem has decay, we'll put the y-intercept at the top of the y-axis. The point asked for was 7, 33. Since it has decay, this point will go in the bottom right-hand corner of the first quadrant. Once we have our two-order pairs graph, we'll connect them with an exponential decay curve. This gives us the function of the number of cockroaches as it depends on the number of days. In this video over exponential functions, you've learned how to read a word problem and identify the starting amount and the common product. Then you plug them into the formula, y equal ab to the x, generated an amount, and then draw an exponential decay or an exponential growth curve. This Pentagon T Tubes Graphics Always Believe video over exponential functions application problems has been sponsored by Pentagon T. Do you need to believe? You need Pentagon T.